So welcome everyone. Thank you for joining. We are running this session twice, so I know more people will join onto the other session later. My name is Christopher Jones. I'm a product manager in the database group at Oracle, focusing mainly on scripting language APIs such as python-oracledb, CX-oracle, and our node.js driver. Also have some responsibility for things like SQLnet layer and instant client packaging, things like that. I'm the only person from Oracle on the call today because of the various time differences, but you're welcome to ask me questions and I can certainly follow up if I don't know the answers at any stage. So today, wanted to keep it relatively technical. I do have a few intro slides just speaking about our new thin mode, what it kind of really means. Wanted to speak about the direction so you kind of know where we're going, and particularly about this Global Developers Program for Python, which I know some of you are here to hear about. The Zoom session that you're joining today, the office hour session, is just open to the public. Tend to get a few questions on chat every now and again. The Global Developers Program for Python, we want to really do a deep dive. We're going to have many more Oracle people on, upper level management, all that sort of thing. So you'll be able to really express your opinions, directions, talk more freely because we have a limited set of people, but I'll go into that later. And then we're going to finish up with some proper driver usage tips, some code there to look at. So a couple of slides of history. You might have seen these before. I think Veronica actually did these in the last session, but always worth covering for people who weren't there. CX-oracle was the driver for accessing Oracle database from Python for a long time. Began back in sort of 98, 99. I think we're settling on 99 for our slides now. Created for a much older version of Oracle by Anthony Tuaninga. We began as a company contributing to the driver much later, 2014. And then we actually hired Anthony in about 2016. He's been maintaining our driver since then. And apologies if you can hear some drilling noise in the background. It's just unavoidable here at the moment. We have tried to make the driver and drivers that we're dealing with much more usable over the years. So we refactored the driver at one stage to use what we call this ODPIC layer. The real key thing there is that this lets us plug and play with the versions of the Oracle client libraries which needed to be installed. So no longer was a tight coupling. You didn't have to rebuild CX Oracle when you had to upgrade your Oracle client libraries from 11 to 12 or something like that. Now you can do drop-in. ODPIC handles all of the changes in the middle. We also did something with Instant Client, which many of you are using. So the thick client mode, we made it available without a click-through. So you could start scripting downloads, you could do Docker containers, all sorts of things. So we're trying, obviously, to make things more flexible for you as developers. And then last year, we released an upgrade to CX Oracle, which we renamed just to python-oracledb with a thin mode, which I'll talk a little bit about. Certainly the most popular of our drivers, the Python drivers. So in the open source space, you know how big Python is out there. Gets used for all sorts of things. So the need to know slide, if you go home with just this, need to drop off. It's obviously the driver for Python now. It's a renamed major upgrade of CX Oracle. So it is CX Oracle, just has a new name. Unfortunately, it's got a new repository on GitHub and similar things like that. Not a huge issue for most of you. So it has this fantastic new default thin mode, which is the focus of today. Don't need to use Oracle client libraries. They are optional if you want to use those, and I'll go into why you might want to use them later. Installs, much easier, single step install, done. You can start accessing Oracle database directly. Because it's a thin driver, without needing Instant Client, you can access Oracle database from platforms where Python runs, but there isn't Instant Client, or it's difficult to install Instant Client, such as Internet of Things devices. We have support and maintaining support for upcoming versions of Python. Currently, of course, 3.6 is out there. That's a sort of standard baseline on a lot of the Linux distributions, so we support that. And then 3.11 is a standard production version. So we have packages out there ready to install for those versions. Open source license still, binary module for performance. So though we call it a thin driver, it's not written in Python. That would just be very slow. It's actually written in Python and then compiled down to a binary for performance. And key thing is it has this Python DB API v2 support. Makes it really usable in frameworks. So those are the take-home points if you need to know anything. The thin mode, without Instant Client, without Oracle client libraries, faster because it's better integration with the runtime. And users are really happy with it. Just that quick install, ready to go. So what are thin and thick modes? Well, thick mode really is what CX Oracle is. Thin mode at this stage is a subset. They both support this DB API v2. They can do SQL. You can do array operations, standard data types, including JSON, very important. Named objects and collections let you do all sorts of things with spatial and pandas and things like that. Has a lot of connection pooling support, or connection support for creating connections, unplanned, planned maintenance. DRCP, I'll talk about that if you don't know what that is a little later, and connections to our various autonomous databases or any database you have TLS enabled. So thin mode connects directly to Oracle Database 12.1. So it doesn't connect back to 11.2. That's a technical decision we took. Would actually be quite a bit of effort to make that happen. And 11.2 is kind of end of life, so we're kind of moving forward. Thick mode does connect back to the older version. So if you need to still use an existing old Oracle database, just install Instant Client and continue using driver just as you did with CX Oracle. The thick mode also supports some of our advanced features at this stage. These are quite complex things. I admire the engineering which has gone into the Oracle Client libraries to support all of these things. Native network encryption, application continuity and transparent application continuity, advanced queuing, continuous query notification, and document access, the SODA support there. Other than that, the drivers, thin and thick modes, it's one driver, you just install it, runtime choice to use thin or thick, depending, you obviously have to have Instant Client installed. And then if your feature set, you don't need any of these advanced features, just use thin mode. And one quick install command, it's up there on the PyPy repository, just install Oracle DB. Optionally, script and download these Instant Client libraries. And you can see that adds a considerable amount of size. Maybe nowadays, the current disk spaces, it's not as big as we used to think it was, but still, it's an extra download, extra step to install, extra configuration in terms of setting up library paths and things like that. So thin mode has space and install benefits. Very active ecosystem. So I mentioned the DB API v2, so that lets it be used in a whole bunch of places, frameworks, Django's and SQL Alchemies and things like that. SQL Alchemy 2.0 supports the namespace because, of course, we changed the names. So SQL Alchemy 2 supports that directly. There's a little bit of like 3 or 4 lines in our documentation of just how you map the names if you have an older framework version and you want to use the new namespace, the new python-oracledb namespace. Django, there's a PR which is taking a very long time to land out there on GitHub to merge the support. Again, you can just add that little bit of boilerplate code in if you want to use Django with a new namespace. The packages are on PyPy. So that's where the pip install comes from. It's also on CondaForge. Thank you to the community member who submitted that. It's also in standard Linux repositories, Oracle Linux, Debian, and Ubuntu repositories. So it's easy to use, available everywhere. Also very popular, of course. Containers, there are containers out there, and this is just one standard way to install. So we actually have RPM packages, as I mentioned on the previous slide, for Oracle Linux. So enable this channel, the developer release Enterprise Linux 8 channel. And when you install Python, you can install Python 3 OracleDB as the RPM package. Could alternatively install using pip, that's up to you. So that was a sort of brief 10,000-foot view. Just a couple of slides on this, because I know some of you are here particularly for what's happening with the Global Developers Program. It's very important to us, an ongoing program. And I want to talk a little bit about the direction before I get there, and then we'll go into the technical things. So today we should be done pretty quickly. So our vision, as you saw, make things easier to use and install. We had ODPIC, we had the no click-through of Instant Client. We've now got the thin mode, so it's easier to use, smaller and faster. That's our general goal. Frameworks, we know a lot of people are using frameworks, so we've been doing a lot more work there with the framework community to try and make sure that best experience of using Oracle database is available to you. Obviously, if new database features come in, and we've started seeing them roll out with Oracle Database 23c, the free edition is out there, we're starting adding support. The Boolean data type support in there is already there. The features to support faster connections and things which are out there actually on our GitHub branch code for the driver at this stage, but not in a release driver. So we've got a whole bunch of features coming downstream for that for you. So that's a kind of given. Want to continue adding some features from thick mode into thin mode to make thin mode even better. We've got multi-cloud support, so we have tokens, so you can connect with tokens like Azure tokens if you're trying to connect through to database and you want to use an Azure token for your authentication. One request which has come in from you as community members is async IO. So everybody wants this parallelization, and Anthony Twinninger is busy looking at that. It's been a long ongoing project. He's been experimenting with different ways to do that. We've made actually some changes into the 23C database itself to be able to support that a little bit better as well. So, it'll work with all versions, but even better with the latest version of the database. And finally, of course, the Global Developers Program for Python is a big initiative for us starting this year. You actually run it internally with our internal users. Python's really big inside Oracle, so we had quite a number of people onto a session there. So Veronica has been spearheading this. You saw her name at the start. So we want to get a select number of you. We're going to keep it relatively small so that we can get better one-on-one discussions, particularly across Zoom. It's hard with the bigger groups. Developers, data scientists, development managers, technical people who know where you're heading. You could be architects. So we want to run this regularly. Obviously, you may not be able to attend every session. But a half-day session, I think we're sort of targeting about 3 hours for the first session. So this is particularly important to us, and it's particularly important, I think, for you, as I've always said when I speak to developers and community out there. You need to be talking to us about what you need, because if we don't know, then we're just busy doing things in a vacuum that we think you might need, and that doesn't benefit either of us. We could also do one-on-one sessions with you as well. So if you want to follow up, don't want to talk in public about some of these things, because it is still a public session. There's no NDAs, no non-disclosure agreements, nothing like that. So it's relatively lightweight to attend. But we do need to sort of know who you are and what you're doing, and make sure that you are going to contribute back to us, not just listen. If you want to listen, you may as well attend things like these office hours and just ping us on Slack or GitHub issues. So I put the details up there. Please send your names, companies, roles, bare basics to Veronica and myself. We're targeting, we've scheduled a couple of sessions towards the end of this month. It depends which time zone you're in, like the 25th, 1st of August, 25th of July, 1st of August. These things are going to be running, so we've got a couple of sessions to suit various time zones. Please get your names in ASAP and get your friends' names in as well if you want to be enrolled in this more inclusive role where we have a bigger audience of Oracle people listening to you and more technical people on hand to answer questions and things like that. So this is really critical for us, and you as users of the driver. What you want, we don't know. Which frameworks are you using? What install problems are you facing? Do you have connectivity problems? Are you trying to run in different clouds? With different other products? Just let us know what you're doing. So send in your names to either of us, or both of us, and we can send you back just a little bit of a form. You can sort of fill in a few more details so we know exactly which products you want to talk about on the day, and then Veronica will set you up with the login information, not the login information, the conference webcast session information. Okay, that was it. 13 minutes of introduction, lightning pace. Wanted to speak a little bit about some of these technical sides of how you use the driver, what the differences are. Let's look at the driver itself. So python-oracledb, I mentioned, is just the upgrade to CX Oracle. It has this new thin mode. Thin mode is enabled by default. If you want to enable thick mode for any of those advanced features, you have to call init Oracle client. That's just the way it is. So on your Mac OS, Intel, where we have instant client, Windows, you call init Oracle client. You could optionally pass this libdir parameter in, saying where the instant client libraries are. There are some options in our documentation you can look at. On Linux, reasons I can't really go into, you have to call or should call without passing a libdir parameter. You need to set your library search path, your LD library path, or your run your system config. You need to run that before you actually start your Python process. And if you don't call it this function, you're just going to be in thin mode. So it's that simple. You're in thin mode by default. If you want to be in thick mode, just call init Oracle client. And then you can connect. And the one change perhaps from CX Oracle that you should be aware of is that now We have better compatibility with that DB API v2, and you need to use these named keyword args, user equals password equals DSN equals when you're connecting to the database. There's one exception to that in the documentation, but you can't just put Scott, Tiger, localhost. You actually have to say user equals Scott. So continuing our theme of making things easy for you, we're trying to get rid of some of these Oracle configuration files, which you have to carry around, maybe some platform-specific issues. So in our thin mode, there are a lot of connection parameters you can pass. Unfortunately, there isn't the plumbing in the mid-tiers to let us do this in thick mode as well yet. We kind of would like the various product owners inside Oracle to enable that. But for the moment, if you want to use thin mode, it's really great, because if you want TCP connect timeout, if you want to get an error message back to your users and not wait for an hour or whatever network's going to time out when it can't connect through to a host, you can pass that TCP connect timeout. If you want to enable sort of keep alive, if you have a firewall which is going to kill you off every couple of minutes, if there's an idle socket, you can set expire time, 60 seconds. So you do ping every 60 seconds across the network to keep that network alive from the firewall point of view. If you have issues with out-of-band breaks, if you're using an older version of Oracle, maybe the auto detection is not working properly, as it doesn't in some Docker containers we know, you can set this in a connect time parameter. In thick mode, you would need to set some of these externally in our Oracle Net configuration files, as explained in the documentation, and you might be familiar with. So I've shown you two things here in the slide. One is how to do things in thin mode, and I've talked about some of the most common options that people would like to set to make their applications highly available and reliable. I have to, of course, I think it's in my contract now that I have to talk about Oracle Autonomous Database, so bear with me. In thin mode, we actually use a different wallet format because we use a Python stack for the cryptography underneath. So we use this PEM file mode. So that's in the wallets, which you can download from Oracle Cloud if you're using ADB, Autonomous Database. And you can see we're passing in the configuration dir and the wallet location. And with PEM wallets, we need a password. The cloud people decided to put a password on them, so we have to pass a password in. Again, if you're using thick mode, you would do some of this stuff with, let me do this bit. With thin mode, you have the benefit you can pass in different configuration directories every time you call connect. So if you want to connect to two different databases, you can have two separate directories with these configuration files in, and there's no problem. Thick mode, these parameters tend to go in SQLnet.aura files, so it gets a little more complex, but you can actually fiddle around with the connection strings if you do need to connect to multiple databases. I kind of put this up here because it was an FAQ for a while that people were asking us about. Bottom line, of course, again, thin mode, easy connect. Thick mode, you have to use some external configuration files. So there are a couple of differences if you're upgrading or you need to swap backwards and forwards between the two. Apologies for that. Plumbing's not quite there yet. And having mentioned all these wallets, download from Autonomous Database, you can configure Autonomous Database with one-way TLS, and then you don't need to do anything on the client. You've effectively set your network or your IP address that Python can run on, that the database will accept connections from, and you just connect with your normal username, password, credentials. One-way TLS is also going to be technically faster. There's less overheads on it, so this would be recommended. Continuing on along the theme of connections, we support pooled connections. And I'm putting this slide up for those who haven't played with the new version of the driver. Because we don't have the thick Oracle client libraries, we don't have what they call in that namespace the session pool, which was always confusing anyway. So we've now got an alias for the name. So if you're using oracledb.sessionpool, that'll continue to work, but otherwise you can swap to the new namespace, modernized namespace, and just say create pool. There's aliases for the same things. And obviously with pools, it's a client-side pool, as we call it. In Python, there's a pool of connections, highly available, ready to run when you need them. Scalable, you can set minimum, maximum, shrink times if you want things to grow and decrease. So you'd use pools if you have lots of connections that will be used concurrently. They'll be used for short times. Pools mean that the pipe across the database and the server process that thing in green doesn't have to be created and stopped, so it reduces the cost of setting up and tearing down connections. They offer some great things like dead connection detection. Every time you try and use a connection from the pool, what we call check it out from the pool to a connect call. there's some extra dead connection detection stuff going in there, which is really great because it means your applications can again be more highly reliable. Once you've got connection with the pool, it's just like a normal pool, a normal connection for those who haven't looked at it. So pool.acquire just says, give me a connection from the pool. And then obviously with that connection, you can do whatever you like, queries, inserts, updates, or SOTA operations. Now, if you're using a client-side pool, you can also take advantage of what we call database resident connection pooling. So I showed you the pooling in the app tier before, which would be that sort of bottom left bit. We also have a pool of connections, the server processes in the database tier itself. So if you have, sorry, actually this is dedicated, sorry, this is the current model dedicated connections. So there's a one-to-one correspondence between what you're doing in the application tier, and this is showing like two processes on the left connecting to the same database, one-to-one correspondence every time the app wants a connection, whether it's pooled or not in the connection, it's holding onto a database resource, those boxes there in the middle on the database tier. With database resident connection pooling, we can break that. If the app is not actually using a connection, if it's idle from the application's point of view, somebody else can be using that database resource. So the database end of the pool of the connection can be reused by somebody else. And so there's just a pool of connections there in the database, connections, pool of server processes available for any application user that wants to use them for a short period of time. There's some caveats in the documentation about connecting as the same user, using them for a short period of time, have similar session state, etc. And those just make everything work better. As always with rules, there are cases when that wouldn't matter, and you'd still get benefits from using a DRCP pool in the mid tier. You wouldn't use DRCP if your database was able to cope with all of those connections on the left-hand side. If it was able to cope with as we showed there, those 3 connections, you're not running out of memory with 3 connections, there's no reason to use DRCP. But by the time you start scaling up and you've got more application processes running and they're doing different things and they're starting and stopping, then the DRCP pool starts to make a lot of sense. So when you have thousands of clients, as we call them, thousands of connections, maybe thousands of processes, using connections for a short period of time, that's when DRCP comes in. This is supported in both thin and thick modes, so you can take advantage of it no matter which you're using. So just in terms of the memory, there's a little bit of a breakdown of whether it's which end of the process is being used, brokers and things like that. I don't need to go into details. So the bottom line is a summary. With this particular fake scenario, 5,000 users trying to do something might end up using 42 gigabytes of database server memory. You can reduce that down to 1 gigabyte by enabling DRCP, assuming this 100 server processes works for your usage case, where depending how long you hold onto those connections and how much work you're trying to do on them, you might need to tune the pool. But certainly we're seeing a number of customers interested, and interestingly enough, there's been a spike of interest recently in this as well. So how do you use it? There's a whole technical brief out there with discussions. You need to start the pool. If you're using autonomous database, the pool's already there, so you can skip this step. Need to create the pool, session pool or create pool, whichever syntax you want to use. I'm showing there in the white text a different way of setting the parameters there. For thin, you can pass the host and port and service name as separate arguments if you want. We have this mid-tier connection pool as well, obviously create pool. So we've got a size, and you notice I'm using fixed sizes for the pool, for the application tier pool. That's because our real world performance team like to see fixed pool sizes. They think that anything else causes contention on the database side, which sometimes you have to deal with. But the key thing there in the green is that you would specify some way of saying, hey, I want a pooled server from the database side, and you can do that in various ways with the connect string or this argument here, server type. We absolutely recommend setting a connection class, which is the user's chosen string, and all of your processes running the same application would use the same class. It's a way of setting a logical partition in the database resident connection pool so that resources can be reused and not shared with other applications, which maybe you want to clear the state and session state and get some new session state for a different kind of application. But anything which is running my demo, you'd use the my demo connection class. Purity also speaks about this reuse of the server processes and the memory there, and whether or not they're allowed to reuse it or whether it has to be recreated. Self is the default and is best practice gives you that, gives you the best performance. So that's it for connection management. Just to keep things brief, we're kind of getting up towards the half hour. Wanted to give you some other best practice tips. These are same for thin and thick modes. But every time I do this, then I know that more people out there haven't heard it. So I think it's worth repeating. So for tuning, when you're fetching a large number of rows, table you don't really know the size of, set cursor array size. Generally, you'd want to set the prefetch rows. We have two tuning parameters for internal buffers. So these internal buffers, they don't affect how rows get returned, when rows get returned to your application calls. Some of you know that fetch one, fetch many, fetch all. Nothing doesn't affect any of those, just affects our internal buffering. How many rows can come across the network in one chunk reduces the time that the network listener has to wake up, maximizes packet transfers and things. So if you're doing a big transfer, definitely want to bump up array size, 1,000, 5,000, probably don't need to get any bigger than that, but your tuning will tell you. And then this particular example just as a fetch many. Obviously, the fake scenario is that you're fetching a huge number of rows that they can't all be held in Python's memory at one time, so you have to fetch them in batches. This will fetch in the default batches. They're the cursor array size batches anyway, so it's all nicely tied up. And you can see if I had played with the various values of prefetch rows and array size, the defaults in the top two for prefetch rows for array size, you'd have to do 101 round trips to the database between Python and the database, get row, get rows, get rows, get rows. By bumping these things up, prefetch rows to 2, array size to 1,000, you can reduce that down to 11 round trips. Bottom row, bumping up prefetch rows to 1,000 hasn't really affected much, but will, certainly in thick mode, add more memory. You have to have 2 buffers, one for a prefetch row buffer and one for the array size buffer. These operate at different levels, and I've stopped trying to explain why, because it gets very confusing, but yeah, if you ever bump into me, I can draw it out on the whiteboard for you. Bottom line is, big number of rows, just tune array size. But if you're fetching rows for paging, so if you know you're going to fix set of rows here in the select query in the green there, you can see I'm fetching 20 rows at a time. Actually, in this case, I'm just only fetching 20 rows. I guess I could repeat this with different offsets and fetch and go through page by page by page. The key thing here is to bump up prefetch rows with that +1 value, so 20 + 1. That avoids some extra overheads of a round trip to detect end of fetch. And again, you can see that if I set both of the prefetch rows and array size at 20, it'd take 2 round trips because I'd have to do that extra check to see if there's end of fetch had been reached. Bumping up to 21 means I've done optimal transfer. Special case of this, of course, is when you're fetching just 1 row. And yeah, you could drop everything back down to cursor array size to 1 if you like, which would reduce memory size allocations inside. Again, your tuning will tell whether it's really worth doing at all. Again, those are internal buffers, only affect transfers between database and Python. Fetching lobs. So this is a standard way of fetching lobs, and what you end up with is kind of lob locator. It's the Oracle traditional, everybody's going to use video method, and then they thought everybody be streaming, so you're kind of querying and fetching chunks of data from the lob itself. This requires a lot of round trips. Actually, it's not particularly efficient. When lobs are under 1 gigabyte, or you've got enough memory to store them, you can fetch them directly as strings or bytes. So this is the code. This is new in python-oracledb. It wasn't there in CX Oracle. You can now set this defaults object fetch lobs equals false. It says don't fetch it as a lob object, just fetch it as a string or byte. And obviously you're doing exactly the same query, but you're just getting the data back directly. And you can see that the difference benefit between the previous slide and this slide is significant, reducing round trips. And this is some little scenario. I forget exactly the data sizes that we're using. Again, your network speed, your data sizes, you're going to need to tune and check what's possible for you. For those who are using CX Oracle, might be more familiar with the handler, the fetch handler type. Sorry, the output type handler. So these two things do the same. You can use both in python-oracledb. You can only use the bottom one if you're still using CX Oracle, but they do the same things internally. Again, they reduce round trips to the database, and it's okay for up to 1 gigabyte sizes of the lobs, which many people are using. One difference between thin and thick modes, remembering thick mode is effectively the same as CX Oracle, is that we don't have all of the national language support libraries implemented, and no real plans to do that. Big overhead. Python has fantastic globalization support already. So we have type handlers, which have existed for some time. And this is one example as another abbreviated example in the documentation if you want to look at this. And I guess I'll just draw your attention to the fact that we're basically using this string format from time, using some kind of locale information here, just set to a kind of German locale. Setting up this type handler means that when we just do our select sysdate from Joule, type handler kicks in automatically, and the data comes back to the user at that print command in the format that was specified with the type handler and the out converter. So that is one difference to be aware of. Just think carefully about it. Think carefully about globalization. Dates, times, those things are always important when you're upgrading from one thing to another. So just do your due diligence. Make sure you're checking both sides of the clock changes and things like that. Next topic, batch execution. Actually, this is exactly the same as CX Oracle. So this is the same thin, thick CX Oracle. Again, just giving you best practice because a lot of people don't do this. You're saving those round trips. I've mentioned how important round trips are. So if you want to insert lots of data, put it in appropriate data structure. I have something there called set input sizes, and that's just telling Oracle, this is the maximum amount of memory that you're going to need to allocate for this particular data size in the transfer, in the internals for the transfer. If I don't do that set input sizes, things will still work, but I might need to do the driver might need to do some reallocs if as it scans through that rows list and it sees something really big. So the set input sizes is useful. The none says use the default type. We've got a number there in the first column, so we just got a fixed size for that. So there's nothing special to be done. 20 is just my arbitrary size I've chosen for this example, where the table's probably got a 20 varchar width. And you call execute many. Done. Data's inserted. Effectively one round trip. And this has significant performance benefits. The orange is the execute many. The blue is if I'd had to loop over and do 7 calls to execute to insert those 7 rows. Obviously, the data sizes on the graph are showing different numbers of rows. But if I'd had to loop on the right-hand side 10,000 times, you can see the difference in times. What's that, 600 milliseconds versus under 30 or whatever it turned out to be for the execute many. A good tool to know. Execute many has a great way of handling noisy data, which you're often doing with big data. So in this particular case, we've got a couple of duplicate keys, 1018's repeated. Parent key 75 probably doesn't exist or doesn't exist in this scenario. But we want the rest of the data to be inserted. We don't want everything to fail. So by using this batch errors flag equals true, you can see in the green, the insert gets inserted. The data gets inserted that is valid. And the invalid data you can scan over here, pointing out that there are 2 errors, that there was a duplicate key at offset 2, so counting 0, 1, 2, and then 3, 4 has the parent key not found. So the thing I haven't shown here, but I did mention and want to reinforce, is that the valid data does get inserted into the table. So you can commit at that stage if you want, or you could go and fix up these 2 bogus data things, insert them, and then commit everything as you like. But it means that you can handle noisy data. It's, quite often logs, you perhaps don't even care if 1 or 2 things fail. Next topic, I'm kind of covering a bunch of things. We haven't run office hours for a while, so I just wanted to give you an overview instead of having a focus area. JSON is getting more and more popular, more and more important. Oracle database is adding more and more features. The Oracle database 23c added JSON duality views, which are a fantastic way to use JSON. I'll let you go and read about that. We might do a second session or a separate session on that later. Basically, the The thing to be aware of is the difference between using like an Oracle 19 database and an Oracle 21 or later database. There's a specific data type was introduced in between. You can use JSON in both, but it was stored as generally as a lob in the older versions, and now it's stored in a specific, much more efficient data format in the current versions. And you need to know whether the clients and databases can talk and understand that new efficient format. So this, as I'm speaking about here, is just JSON stored in database 21C. We do have examples on GitHub with the older versions if you want to look at those. The thin mode knows how to deal with this. You need to understand if you're using the thick mode, then you need Oracle Client Libraries, which are also 21C, so they know how to deal with this new data format. And you can just bind that, I'm going to call an object, the data object at the top, lists, whatever you want to call them, dictionaries, that you can just bind those and insert them into the database JSON column. So assuming we have a column which is of type JSON. If you're using something else, an older version of the clients, then you have to actually just do some conversion into string yourself in the application. Fetching, similar kind of thing. If you're using thin driver or smart client version, the newer client versions, you can just execute, and python-oracledb, CX Oracle can actually interpret and get that JSON back for you as an object which you can deal with directly. If not, you have to kind of exploit it with the JSON loads functionality. So that's just the kind of watch out there. Make sure you know which versions of the database you're targeting. Make sure you're testing with that version that you're going to actually deploy with as well. So that's it for today on the technical tips. Certainly Q&A is open, as it has been open for some time. So if you do have questions, pop them up. I'll put up this resources slide. And again, we have the Global Developers Program, which I carefully don't have there on the slide, so apologies for that, but the contacts are down the bottom, Veronica and myself. So if you want to be invited to the Global Developers Program, get that better access to a high-level management, express your frustrations, not just about the driver, but about interactions with Oracle Database as well. Please email myself and Veronica, your name, role, and company. We've got those sessions coming up towards the end of the month, start of next month. So 25th and 1st, depending which time zones you're in, and you can join one or you don't need to join both because they're the repeats, but you can join one of those. But that's our big initiative going forward, that we really want to extend the model that we've been using successfully with JDBC and our .NET area, where they've had customer advisory boards, and they're moving actually to this new model, which we're piloting, this Global Developers Program, lightweight. We don't need NDAs, so we're not going to be talking about particular futures, but we are going to be listening to you, taking on board what you need, where you're heading, where you think we should be heading as well. So please do mail us with those things, and I can see a question has popped up, and that's just a thank you. So thank you, Piet, for that. And with that, if anybody has any questions, you've got just a couple of minutes, and otherwise I will, oops, I can see a raised hand there. What does the raise hand mean? So if you do want to answer, just, sorry, if you do want to ask a question, just type it in the chat. So I'll give you a few minutes if you do want to type something in. Otherwise, feel free to drop off if you want to drop off. And Veronica will be rerunning this session at a different time zone. So if you have other colleagues in different parts of the world who want to attend live as opposed to watching the video, please just point them to the other session on the page. And I do apologize in advance. I don't know what's up with this DevGym mails they sent out. There were definitely some problems with the URLs and the buttons there. So I'm glad you all managed to join. And that was another thank you. So thank you as well. And also, send in ideas for what you'd like us to talk about in our next office hour session. Seems to be in a long time that we haven't run one. partly because actually with the world going online, we've been doing a lot of conferences. So I was speaking at a lot of conferences about these things. And we've been working hard on our thin drivers. We just had our Node OracleDB thin driver released as well to match python-oracledb. So kind of excited about that. Okay, I'm going to finish up and we'll thank you all for attending, and hopefully we'll see you at another session and another time. Bye-bye.